Hi, welcome back to another video. In this video, we'll cover exercise 2G from the new 2nd edition methods textbook. We're very familiar with linear equations now, and this exercise focuses on using our knowledge in linear equation and apply them to a variety of application questions based on real-life scenarios. To help you fully grasp this exercise, this video will be broken down into two sections. We'll start off with two core examples from the textbook. We'll then practice 3 questions together. Alright, example 22. A historical site charges a tour company for priority entrance to the site. The charge consists of a monthly fee of $200 plus a $3.5 fee for each tourist brought to the site. Construct a cost function that describes the monthly charge and sketch the linear graph for this. Okay, so now looking at the solution, C is equal to 3.5n plus 200. C is the total monthly charge and n represents the number of tourists. Notice 200 is a constant here, okay, and it's always in the equation. This means that the $200 fee is a base charge, okay? So this tour company will have to pay no matter how many tourists it gets. You can have 0 tourists, but the $200 fee still applies, okay? So maybe the $200 fee is still there in order for you to be eligible for priority entrance. So that's why the 200 fee is the base charge, since that's the constant in the equation. This also explains why our straight line starts at C is equal to 200 instead of the origin, because it doesn't matter how many tourists that were brought to the site, we'll always have to pay for that 200 base charge. Okay, an important linear relation is the relation between distance traveled and time taken when an object is traveling with constant speed. If a car travels at 40 kilometers per hour, the relationship between distance traveled, here denoted by S, and sometimes we use D to represent distance, and time taken, so T hours, is given by S is equal to 40 times T, where T is greater than or equal to 0. And that makes sense because T represents time and time cannot be negative. This is a typical example of constant rate of change. Because notice here the graph of S against T, so this function here, this straight line graph passes through the origin, which is 0.00. Why? Because there's no constant, there's no C term in this equation, right? So the gradient of this graph is 40. It has a positive gradient, therefore it's increasing at a constant rate. If you want to learn more about constant rate of change, average rate of change, and instantaneous rate of change, please see links in the description box below and check out previous videos. So we're not going to spend too much time here. Okay, in this example, we're looking at a car starts from point A on a highway 10 kilometers past the Wangaratta post office. The car travels at a constant speed of 90 kilometers per hour towards picnic stop B, which is 120 kilometers further on from A, and let T hours be the time after the car leaves point A. It's very wordy. Let's actually draw a picture to represent this relationship. So let's say the car started from here, which is point A. That's the post office, okay? And this is point B, the picnic stop. We know that the car started at point A, which is 10 kilometers past the post office. So we know this distance here is 10 kilometers, right? And the car is traveling towards B, which is 120 kilometers further on from A. We know the distance between A and B has to be 120. So using this diagram, hopefully it can help us to solve the question. Let's see what question A is asking. Question A says, find an expression for the distance D1 of the car from the post office at time T hours. We know distance 1 is equal to the distance the car already traveled, right, which is 10 kilometers, plus the distance it continues to travel at a constant speed of 90 kilometers per hour. So t represents time, and time t multiplies by speed 90 equals distance. So d1 is equal to 10, which is that 10 kilometers that's already traveled, plus 90 times t. So it's quite easy. Second question asks, find an expression for the distance d2 of the car from point B at t hours. So distance d2 is equal to distance from point B. We know the distance between A and B is 120 kilometers. Subtract the distance the car already traveled from point A. We have the distance from point B. Okay, so d2 is equal to 120, which is the total distance between the 2 points A and B. So 120 minus 90 times t. So this should represent the distance of the car from point B at time t hours. Okay, question C. On separate sets of axes, sketch the graphs of d1 against t and d2 against t and state the gradient of each graph. Plotting the graph isn't difficult. We just need to make sure we correctly label the starting and end points. And identify the correct gradient is also really important. So d1 has a positive gradient, and the starting point is 0, 10. This makes sense because we start at 10 kilometers from the post office. When t is equal to 0, the car is just starting its journey. It's already 10 kilometers past the post office, so this explains our starting point. The end point is the end of the journey, which is when the distance is 130 kilometers. Note the 130 kilometer here is equal to the initial 10 kilometers plus the 120 kilometers between points A and B. So if we're subbing d is equal to 130, we find t to be 4/3 hours. So it took the car 4/3 hours to get to point B. Now, look at d2 graph. d2 graph has a negative gradient. The line is decreasing. The starting point is easy. It's 0, 120, because when time is 0, the car is 120 kilometers away from point B. The end point here should be the same when the distance becomes 0, since d2 denotes the distance between points A and B. When the distance between these 2 points becomes 0, it means that the car has arrived at point B. Okay, so think of this again. When the distance between these 2 points becomes 0, it means the car has finished traveling, right? It has completed its journey. And if we compare the two graphs, when the journey is completed, time taken is 4/3 hours. So accordingly, when the journey is completed, the time taken will be the same. So 4/3 hours with the distance being 0, because there's no more distance to travel. Okay, so this question is actually really tricky. We need to be very careful when comparing these two graphs. Although they seem to represent the same journey of the same car between 2 points, the distance d1 and d2 are actually measuring different things. That's why we should always read the question carefully so we don't make mistakes easily. But otherwise, this is a really great example because it's looking at the variables we often deal with, so distance and time and speed. So please constantly refer back to this example as you go. To help you understand linear models better, let's practice 3 questions together. You can find these questions in your textbook exercise 2G. So here we're looking at 2G. Another tip that I want to mention quickly that not everyone knows is that next to question 1, you can see example 22 here. And then you can see example 23 next to question 2 and all the way to question 10. Since there are only 2 examples in this exercise, it implies that question 1 requires us to use skills and strategies demonstrated in example 22, whereas question 2 through question 10 require us to follow strategies demonstrated in example 23. This is always the case, it's always applicable in your textbook. So when you're doing exercise questions, feel free to refer back to these examples because you probably need to use a similar method. So when you're doing revision as well, look at the examples from each exercise. They are the type of question you might expect to see in a SEC, for example. So keep this in mind. All right, so question 1 says the weekly wage, $W, of a vacuum cleaner salesperson consists of a fixed sum. So fixed sum means that's the constant, $350 plus $20 for each cleaner sold. If n cleaners are sold per week, we're given the variable. Construct a rule that describes the weekly wage of the salesperson. So fixed charge means it doesn't matter how many cleaners were sold, the salesperson will always get paid $350 every week. And obviously, the more cleaners he sold, more money he will make. And the extra money is denoted by $20 per cleaner times the number of cleaners sold, which is n. So we can easily figure out the rule. W, the total weekly wage, is equal to the 350 fixed sum plus $20 per cleaner. And we don't know how many cleaners he sold, so that's why we're using n, the variable, to represent it. But one thing we do know for sure is that he will always get paid $350 as the weekly wage. Okay, so that's our final equation. Okay, question 6. A car rental company charges $85 plus an additional amount. So here, let's remind ourselves that the $85 is the fixed charge. It's the constant in the function. And plus an additional amount of 24 cents per kilometer. 24 cents and $85, they have different units. So we need to be very careful here. First thing first, we actually need to convert 24 cents into dollars. So we can do this quickly, and we can just write this down quickly to remind ourselves that we need to make sure the units are consistent. All right, question A. Write a rule to determine the total charge, C, for hiring a car and traveling X kilometers. So the total charge is equal to the $85 we'll have to pay plus 24 cents for every kilometer traveled. Now, 24 cents is equal to $0.24. So we just rewrite this in dollars, which is 0.24 times X, since X denotes the kilometers traveled. So this is question A. Question B. What would be the cost to travel 250 kilometers? 250 kilometers should be the value we sub into X, since X represents the distance traveled. So let X equals to 50. C is equal to 85 plus 0.24 times 250. And the total cost is equal to $145. Okay, last question. A printing firm charges $35 for printing 600 sheets of headed notepaper and $47 for printing 800 sheets. Question A. Find a formula assuming the relationship is linear for the charge, C dollars, in terms of number of sheets printed, N. Alright, firstly, let's set up an equation. Let's say C is equal to Mn plus D. Be very careful here. C represents the total charge. N represents the number of sheets printed. M is the gradient. Okay, so M is not a variable. M is the gradient. Because usually it will be Mx and X being the variable. But here the question told us to use N. So don't get it mixed up because N just sounds very vague, but N is the true variable here, M is the gradient. D denotes any fixed charge that might exist. We don't know if there's any fixed charge. We don't know that yet. All we know is that this relationship is linear. There could be a linear relationship where the the line passes through the origin, which means D will equal to 0, but we are not sure, so we have to find out. So here are our coordinates. The coordinates will be printing N sheets of paper and the cost. So it's N, C. When printing 600 sheets of paper, it cost $35. And when we printed 800 sheets of paper, we paid $47. So these are the two coordinates we'll be using to solve the simultaneous equation. Now let's set up the equation. So $35 is equal to, we don't know gradient, we don't know M, number of sheets, N equals 600, 600 times M plus D, we don't know D yet. $47 is when we're printing 800 sheets, M plus D. Let's label the two equations and try to solve them. Since two equations have D in common, we can use elimination method. So take away equation 1 from equation 2, so it's 2 minus 1. D and D are cancelled. 800M minus 600M equals 200M. And 47 minus 35 equals 12. So divide 200 from both sides. We found that M equals 0.06. Now we can easily find D by subbing M is equal to 0.06 into any of the equations, and we found D to be minus 1. So the relationship here is that cost C is equal to the gradient 0.06 times N, sheets of paper, number of paper, minus 1. Okay, second question. How much would they charge for printing 1,000 sheets? This means when N is equal to 1,000, what is C? So C is equal to 0.06 times 1,000 minus 1. 0.06 times 1,000, we can simply move the decimal point 3 places to the right, which becomes 60, and 60 minus 1 equals $59. So it's going to cost $59 to print 1,000 sheets. Alright, hope you find this video helpful, and I will see you in the next video. Bye!